Look up at the night sky today, and you might see a strange line of bright dots moving in perfect formation, humanity's newest and most controversial addition to the heavens.
Starlink is a satellite internet constellation developed and operated by SpaceX, Elon Musk's aerospace company. The goal of Starlink is to provide high-speed internet access to remote and underserved areas across the globe.
Traditional internet relies on ground cables or a small number of distant geostationary satellites, limiting rural access.
Starlink instead uses thousands of small satellites positioned in low Earth orbit, much closer to the planet's surface. This closer distance dramatically reduces signal delay, called latency, compared to traditional satellite internet services. SpaceX began launching Starlink satellites in 2019, rapidly expanding the constellation with dozens of launches per year. Each Falcon 9 rocket launch typically carries around 60 satellites, stacked together for efficient deployment. As of the mid-2020s, SpaceX has launched several thousand Starlink satellites, forming the largest satellite constellation in history. The company has received regulatory approval for tens of thousands of additional satellites in coming years. Starlink satellites orbit at altitudes of around 550 kilometers, much lower than traditional communication satellites. This low orbit ensures that defunct satellites naturally deorbit and burn up within just a few years without intervention. Users access the internet through a small satellite dish, often called Dishy, that automatically tracks satellites overhead. The service has proven especially valuable in disaster zones, providing emergency communication when ground infrastructure fails. Starlink terminals were notably deployed in Ukraine, providing crucial internet access during ongoing military conflict. This use highlighted both the humanitarian potential and geopolitical significance of privately controlled satellite infrastructure. However, the rapid growth of Starlink has generated significant concern within the professional astronomy community. Newly launched satellites are highly reflective, appearing as bright moving dots that can interfere with telescope observations. Long-exposure astronomical images can be ruined by bright satellite trails crossing directly through the field of view. This problem is especially concerning for large survey telescopes designed to scan wide areas of sky repeatedly. The Vera Rubin Observatory, designed to detect faint and rare cosmic events, is particularly vulnerable to satellite streaks. Astronomers worry that increasing satellite numbers could compromise humanity's ability to detect dangerous asteroids in time. In response to criticism, SpaceX has worked to reduce satellite brightness through specialized coatings and sun visors. These modifications have somewhat reduced, but not eliminated, the visual impact on ground-based astronomical observations. Radio astronomers have raised separate concerns about satellite transmissions interfering with sensitive radio telescope observations. Radio telescopes detect extremely faint signals from distant cosmic sources, making them vulnerable to any nearby interference. International astronomical organizations have called for stronger regulations governing satellite brightness and radio emissions. Despite these concerns, satellite internet constellations continue expanding as multiple companies enter the growing market. Amazon has developed its own competing constellation called Project Kuiper, planning thousands of additional satellites. China and other nations are also developing their own large-scale satellite internet constellations. This growing competition suggests the number of satellites in low Earth orbit will continue increasing substantially. Some rural and remote communities have reported transformative benefits from finally gaining reliable internet access. Farmers, remote schools, and isolated medical clinics have used Starlink to access resources previously unavailable to them. Maritime vessels and aircraft have also adopted satellite internet for continuous connectivity during travel. The technology represents a genuine leap forward in closing the global digital divide between connected and unconnected regions. Critics argue that private companies should not unilaterally control access to increasingly crowded orbital space. Questions remain about who has authority to regulate satellite constellations that operate above individual national borders. The United Nations and various space agencies continue debating appropriate international frameworks for satellite governance.
Meanwhile, ordinary stargazers increasingly report seeing satellite trains, chains of newly launched satellites moving together. These trains appear especially bright shortly after launch, before satellites spread out to their final operational positions.
Photographers and astronomers have captured dramatic images of these satellite chains crossing the twilight sky.
Some view this as an exciting symbol of technological progress, while others see it as troubling light pollution. The debate reflects a broader tension between technological advancement and preserving the natural night sky for future generations. Whatever the outcome, Starlink has already permanently changed what humans see when they look up at night. For as long as humans have existed, the night sky remained essentially unchanged above our heads, until now, when a single company's ambition to connect the world quietly rewrote the heavens themselves.